Can you say the output of following code snippet? It's a tricky question to check whether you understood arithmetic operators from previous sessions. I will answer the question at the end of this session. Hi all, welcome to the complete JavaScript beginners tutorial by CodAffection. This session covers how to deal with numbers in JavaScript. We have already discussed numeric data types, number and begin during data type session. Things like different ways to create number and begin variables, range of number values, both safe and unsafe, how to create a begin variable, when to use number and when to use begin type, etc. Here in this session, I want to add few more points to it. First of all, let me show you some classification of numbers. It will be helpful for JavaScript entry exercises. So first of all, we have integers, numbers that can be represented without a fractional part. So these values, both positive and negative, including 0, comes under integers. And then we have whole numbers. They are starting from 0, 1, 2, 3, 4, and so on. And finally, we have natural numbers. They are whole numbers without 0. So natural numbers starts with 1, 2, 3, 4, and so on. So remember these classifications. It might be helpful when you ask to write a JavaScript program to print whole numbers. So you should know what are the values it involves, right? So just have a brief idea on these classifications here. In previous session, we have discussed difference between primitive string and string object. You could find similar objects for other primitive data types also. Let's try primitive number and number object. For that, first of all, let me declare a variable amount and let's initialize that with some random number. Let's print the value to the developer console. Let's duplicate this line and let's print the type of this variable. As you can see, the type of the variable amount is number. Now let me reassign this variable amount using this number function here. Let's pass 45 here. See, it is initialized with the value 45 and still the type of the variable is number. Now let me declare another variable, price. Let me initialize that with this syntax, new number, and then let's pass 45 here. Let's print the variable to the developer console. Let's duplicate this line and let's check the type of this variable. So see, this is what we have inside this variable price after initializing with this syntax here. And the type of this price variable is object. So this is what we are calling a number object. And this amount variable is a primitive number and this price variable is a number object. Here we have called a function number. But while initializing this price variable, we have called number class. We'll be discussing JavaScript classes in a separate session. Now inside this log statement, now I will call the function toFixed from this amount variable. We'll be discussing this function in a bit. This function just limits the number of digits after the decimal point. Currently this amount is having the value 45. There is no decimal point, so it will add a decimal point. Then after that it will provide 2 zeros as we have passed here. Now let me change this number like this. Now you could see the result from this function toFixed. It is limiting the number of digits after the decimal point. So only 2 digits are taken after this decimal point here. Also it will round the number. For example, if we were passing 65 here, you see it is rounding. If the number after the cutoff is greater than 5, last digit will be incremented by 1. So that's how this function works, toFixed. Like we discussed for string primitive, we call a function or method like this amount variable is an object. But it's not an object, but it is a primitive number. But the definition of number itself says they are simple, like this simple number here. They don't have any property or function like an object. Then how we are able to access or call this function like an object? Normally JavaScript object contains functions or properties like this, and they are accessed with this dot or period syntax. So this is what happens here. When we try to access number object functions with primitive number, behind the scene JavaScript creates a temporary object corresponding to the primitive number, and from that temporary object this function is called. You could see this toFixed function inside this number object here. Let's expand this prototype. Here we have the function toFixed. We'll be discussing more commonly used number functions in a bit. Before that, I want to discuss few more things about this function number. There are functions like this for all data types in JavaScript. With that, we can create the value of its type. For example, here we are creating number with this number function. Here we are directly passing a number, so this function returns the same as it is. So that's how this variable is initialized with the value here. Now let me duplicate this line here. Instead of directly passing a number, you can also pass string like this. String containing a valid number. Here the function converts this string number to a number type. If you pass an invalid number here, it will return NaN, meaning not a number. If you pass Boolean values like true or false, it will return 1 or 0. For true, it will return 1. For false, it will return 0. So that's how this number function works. Now let's get familiar with commonly used number functions. Now let's discuss most commonly used functions related to number type. Let me get rid of these codes here. First of all, we have the function parseFloat. So basically this function parses or convert an argument to a floating point number. This is how we do it. Here we have the log statement. We have this class, number class. From that we have to call this function parseFloat. Now whatever we pass inside these pair of parentheses here is called an argument. We will be discussing that in our session for function. So whatever argument we pass to this function will be converted to a floating point number. If it fails to pass or convert the number to a floating point number, it will return NaN. So let's try a few examples here. So here we have the output 345, which is exactly what we have passed here. Let's try another number. So here we have the floating point number corresponding to this string here. Now this will work even if you pass an invalid number after these numbers here. See? So this function tries to pass the first number given in the argument, and rest of them will be skipped. So even if we pass numbers separated with spaces, only this first number will be considered. So that's how this function works. If the given argument right away start with non-valid numbers like this, then it will return NaN. Here we have called this function parseFloat from this class number itself. This is what we call static functions. We will discuss that during our OOP session. To make this syntax more easier, JavaScript added this function to global object so that we can directly call the function like this, parseFloat like this. So this is one of the commonly used function over JavaScript number type. There is another function called parseInt. It parses a string argument and return an integer. So let's try that within this log statement here. We can call the function from this number class like this, parseInt, and this function expects a string. So whatever we pass here, corresponding number integer will be returned. Even if we pass floating point numbers like this, the function will return the integer part only. So that's how this parseInt function works. If we pass an invalid number within the string, it also returns NaN. This function is also added to the global object. So instead of calling this function from class number, we can directly call like this, parseInt. Once you start working with input controls of a form, you will be using these functions for parsing the input from input controls. For now, that's all about our static functions. Now let's discuss the function toFixed. We have already seen how this function works. It formats a number using fixed point notation. Let's try that again here. We have a variable x initialized with some random value like this. And let's call the function toFixed on this variable. toFixed, and let's pass to here. So only 2 digits after the decimal point will be taken. So the number after the cutoff is having the value greater than 5, so it is rounded to 0.09. So that's how this toFixed function works. Try one more example. Here I will just directly pass a number like this, 0.004. Only 2 digits are taken after this decimal point. So that's how this function toFixed works. So these two functions will convert other types of data into number, and this function toFixed convert a number to a string. So these outputs here are of the type string data type. Now we have the function toPrecision. This function returns the string representation of a number in a given precision by means of significant digits. Here the word significant digits is mathematical, and that's what makes this function different. Let's try a few examples here. I will be calling the function directly on numbers. So here we have the number, and let's call the function toPrecision here. Inside that we will pass 4. So this function will return 4 significant numbers within this given number here. So 1, 2, 3, then 4 after this decimal point here. Here the numbers after the cutoff is 56, so which is rounded to 123.5. Let me try a few more examples. This time I will pass this number here. Here we have the output. So by definition of significant numbers, zeros before a non-digit number is not a significant number. So these numbers are not significant. So in order to accommodate 4 significant digits, it is adding 3 zeros here. If you want to know more about significant numbers, you can check out the video link in iCode right now, or I will give the same video link in video description. Now here we have the final function toString. So basically this function converts the number to a string type. Let's try that here. First of all, I will declare a variable y here, and let's initialize that with a number, and let's call the function here y toString. Let's print the value of y here. See, it is not in pink color, meaning it is converted to string type. Let's move this line above this function invocation. See, it is printing the number in pink color, meaning it is of the type number. So this function will convert the number into corresponding string. Now there are two functions. They could do more than what we discussed here. So those two functions are this function toString and this function parseInt. These functions helps us to convert a number to a different number system. So first of all, let me explain the number systems we have. So let me get rid of these codes here. So there are 4 important number systems. So first of all, we have decimal number system. So this is the number system that we extensively use in our real life. So it has 10 simples. That's why this is called as decimal number system. Deci means 10. So inside this system we have 10 simples: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 10 simples inside this decimal system. And then we have binary system. As you know, it only has 2 simples, 0 and 1. Then we have hexadecimal system, and finally octa number system. Inside this hexadecimal number system, we have 16 symbols. So it includes all of these 10 symbols from decimal system. Along with that, it includes these alphabetic letters A, B, C, D, E, F. And in case of this octal number system, we have 8 symbols from 0 to 8. So decimal number system is we use on a daily basis. As you know, this binary system is used to save data in computer memory. An example for using hexadecimal number system would be the color codes for designing a web page. Octa number system is used in operating systems like Unix. So basically these functions parseInt and toString can be used to convert from one number system to other. So first of all, let's look how this parseInt function helps us to convert a number to decimal number system. I will do that inside this log statement here. Let's call the function parseInt. Inside that, as a first parameter, I will be passing a string with some numbers like this. So here we have the output integer number corresponding to the passed string here. So that's what generally this parseInt function does. Instead of a decimal number, you could also let's pass a binary number here. Currently this function treated this number as a decimal number, and that's how we are able to see this value 100 here. Instead of that, if you want to treat this number as a binary number, you could pass 2 here. Here we have the output 4. Since we are passing 2 as a second argument here, function knows this is a binary number, so it converts the number into corresponding decimal number, which is 4. So this function always converts the input into decimal number. So as a second argument, here we are passing number of symbols or radix of the system. For now, you could think of radix as a number of symbols inside the number system. In case of hexadecimal, it is 16. So if we pass F here, and you want to treat this as a hexadecimal number, we have to pass 16. Then we have the output 15. So the hexadecimal F is equal to 15 in decimal number. So that's how this function is helpful to convert any number system to a decimal number. Now let's try toString function here. I'll be calling the function in another log statement like this. I will directly call the function from a direct value like this, 45, and let's call the function here toString. So generally when we call the function like this, it will convert the number to corresponding string like this. Instead of this, if I pass 2 here, if I pass 2 here, it will convert this number to binary. See, if I pass 4 here, it should result 100. If I pass 5 here, it should return 101. So that's how this toString function works. Now let me show you how you can assign values in these number systems here. So first of all, I'll be declaring a variable x here. If you want to assign a decimal number, you just need to directly pass the number here. Instead of that, if you want to pass a hexadecimal number, first of all you have to start the number with the prefix 0, small x or capital X. See, and then provide the number like this. So here we are only passing the hexadecimal number F, and this prefix here is just to indicate this is a hexadecimal number. Let's call the function toString from this x variable here. So in decimal, this is 15. So here we are trying to convert 15 into binary. So here we have the output. If you want to convert this into decimal, just pass 10 here, or just ignore passing any value here. So this is how you can assign an hexadecimal number to a variable. Instead of this, if you want to assign a binary number, just use the prefix 0, small b or capital B. And let's pass the number here 100, meaning 4. So here we are converting the number to corresponding decimal number. So 4. This is equal to 4 in decimal number. In same way, if you want to assign an octa number, you just use the prefix 0, small o capital O, and let's pass the number. Sorry, in case of octa number system, only these much symbols will be there. So 10 in octa number system is equal to 8. So that's how these functions, parseInt and toString functions, helps us to convert the numbers from one system to another number system. Finally, I just want to introduce you the built-in object math. It contains various properties of functions related to mathematical operations. For example, here we have the property math.py. It returns the value of pi 3.14 like this. And there are some functions like trigonometric functions. Here we have the function to find exponential operations. Let's try that here. We have already learned the operator exponential, so it looks like this. For example, 2 raised to 3, we could do that using this exponential operator star star then 3. So it should return 8. The same can be achieved with this function here. See, math dot power 2, 3. See, here we have the same output. If you want to find largest or smallest number from a collection of numbers, you could use these functions max and min. Let's try that here. Let's call the function max and let's pass few values here. So here the maximum number from these given numbers is 5. So here we have the output 5. Like this, you could also find minimum of given collection. So it should be 0. So these functions will give the direct solution to many problems that you might encounter in our applications. For example, this random function will be helpful for developing gaming applications where a random number is to be generated. You may not know these functions exist if you haven't go through this page here, right? So just remember these functions are present within math object. You could use them when necessary. Now let's explain the tricky question that I have mentioned while starting this session. First of all, we have a variable I which is initialized with the value 5. Actually, we just need to find the value of this expression here. So these are two additions, right? And these are increment operators. We have already discussed that under operators session. So this post increment first return the value 5. So let me write that here. So this will return the value 5 first. And then after returning the value 5, this increment operation happens. So 6. So for this addition operation, value of I will be 6. Here we have a pre-increment operation. So first of all, the increment operation happens. So 6 plus 1, 7. So 7 will be returned. So 5 plus 6, 11, plus 7, 18. So the value of I after these two lines will be 18. Let's print the value of I here. Boom, that's it. Hope you found the question interesting. That's all for this session. In next session, we'll be discussing control flow statements in JavaScript. For more awesome videos like this, please consider subscribing to this channel, CodAffection. Please like and share this video with your friends and colleagues. See you in next session.